for would have been a much better thing. But you see, my thought was, all right, we'll get out this RFP and the manufacturers will answer it. And then we will see what compromise we have to make in order to get what we want. But that never got through to Stratton.
At that time, wasn't IBM playing You Bet Your Company on the 360?
Yes, it was.
Yeah, and also they were we found, it came out later, and I didn't realize until later, I think, they were very burned by the Stretch experience.
Absolutely. The engineers
they realized that one of the things that had gone wrong was that the customer had told them what to build. And then when they ended up building everything the customer wanted, that it really wasn't a very useful commercial product. The customer was Los Alamos and behind the scenes at NSA, I assume. So they weren't going to do that mistake again, and they were really convinced. They also had this kind of conviction, which was fostered by the design team, that they had were designing a computer that was good for everybody. And one of the recriminations when the 360 came out, internal to IBM, was that we, in fact, very rapidly reacted and said, hey, this isn't good for everything. And they said, what do you mean it isn't good for everything? Our designers told us so. And they went back to Amdahl, Brooks, and Blau and complained. And they, of course, rationalized their way out of it. Eventually, it led to the 67 aberration.
Yeah, but now, my view of it is that,
we'll get onto that, I'm sure.
For some reason of internal politics, they took an excessively gloomy view of Stretch. And that, in fact, Stretch was a better computer than IBM. Oh. That is, IBM's internal politics took an excessively gloomy view.
From their point of view, they didn't need to build it. They could build a 7090, and which they viewed as a re-engineered, the best of Stretch.
Yeah, they took all this.
They took the
technology from Stretch was the 7090.
Well, now the key thing about Stretch worked as advertised, except that it was slower than.
It's too expensive.
I recall you were very upset about their look-ahead feature. You saw some basic flaw in it. And I think
right, and I still don't believe it. I mean, that was that is, I still don't believe in that kind of elaboration.
That's right.
That's how they got the speed.
That was a crucial flaw.
John, is there any difference between look-ahead and pipelining? Isn't that the same thing with a different subtype?
Yeah, right. I don't believe in pipelining either.
Oh.
Yeah, it's the same.
Now, the subsequent forms of pipelining have been simplifications and cleaned up versions of look-ahead. But basically they require outguessing.
It also requires...
maybe that's not relevant.
No. I say it also requires considerable prudence in the choice of the order code, so that you don't create instructions which are hard to abort and which are not irreversible.
But now, my reason for not wanting the Stretch, that is, for not going along with Herb's proposal of plunking down on a Stretch, was a desire to. I thought we would get something better if we came out with an RFP for a time-shared machine, and it wasn't due to any specific fault that I found with the Stretch.
Wasn't there also a UNIVAC competitor?
No. No, right. UNIVAC had a machine, but it was really like twice a 7090. It wasn't in the same class.
A Stretch. Well, what was the name already?
Jesus. Well, what they came up with was the 1100, 1107, or
no,
1110.
It was a fancy version.
It had a fancy name, like Stretch.
Oh, you mean the Lark?
Yeah, that's right.
Okay, the Lark was a decimal machine done for Livermore, of which they built exactly one, I think.
Yeah.
And Livermore didn't love it. They, in fact, got 2 Stretches in addition. So the Stretch project within IBM had this history that Livermore first came out with the RFP with certain tight delivery dates and certain tight specifications. And IBM looked at that and said, no, we're not going to do that, and did not respond to the RFP, but said we're going to do something on our own schedule, which is what we want, which turned out to be Stretch. And they got Los Alamos to be their first, Los Alamos and NSA to be their first customers on that. Now, the interesting thing is that Stretch had relocation. It had Now, there's some puzzles here. Stretch had relocation and it had boundaries, but it did not have inhibition of I/O. So that any program could have destroyed the machine by initiating I/O to clobber the operating system. And from our point of view, that was a considerable flaw. Now, I say that it may not have been actually so much of a flaw, because if you remember, when IBM fixed up the 7090, they left out a couple of things. And that it was possible for a program to stop the whole machine.
Oh, yes.
Either by an execute self or
There
I
was an
forget what it
instruction
was.
that does stop the machine dead.
Yeah, but we
Can I
we
interrupt?
basically, there were a few
When do
enough
we have
cases we
lunch?
could look for.
That was why I was standing up. It seemed to me that when you reach
a point of break that you're tired, you should get up and get some lunch.
Your discussion kind of refreshes a bit my memory.
We're all going that way.
When the report was presented,
Transistors, we fade.
Jay Stratton took it seriously, and we were moving to get from various companies. And then Phil Bradley went to see Stratton and essentially told him, don't do anything until you hear from us, because we got great things coming out, obviously Blender 360, so don't do anything. And to some extent, that put Jay Stratton to sleep. There was a promise of having something soon, and they didn't come through with anything soon, but Jay Stratton essentially forgot about it. He was uncomfortable anyway because he didn't know where to get the money. So he took the IBM statement too seriously and put the whole thing. Because now I recall being frustrated by the fact that nothing was happening.
But
Well, there was another factor involved, which was that the core memory dispute was heating up at that time.
Okay, all right, that's right.
yeah, we in fact did visit several other manufacturers in that period, because I remember John and I on some trips and visiting around the time that we had an aborted Electra flight. And another time when Seymour Cray snuck into we were out at CDC and we couldn't get any of the top designers' attention. And we were trying to see Seymour, but Seymour was always too busy. He'd already had this aura of aloofness. But in fact, we found out that he had snuck into the rear of a 1-hour seminar you were giving on time sharing, and he listened for about 20 minutes and walked out, deciding on the basis of that brief window of exposure that he didn't think much of the idea and didn't need to change his way of doing things.
Yeah. The thing that I also remember
Sometimes has that effect on people.
clearly is that MIT was by and large sold on the idea of time sharing.
And the manufacturers weren't.
And that's right. In other words, that the community had bought the idea that the future was in the direction of time sharing. And at that point, the argument went something like, we want a big memory. Because there are occasionally things that require a big memory. We cannot afford a big memory unless it is fully exploited. And a way of exploiting it, this is part of the argument, was to have time sharing so that we get the benefit of the large memory all the time, and we have when there is a big user that need it for a short time. That was one of the arguments that I think you proposed. And then later on, this developing the idea of the computer utility and so forth that you presented at that at the the meeting. What was that meeting? Was the 50 the
Management of the computers of the future.
Yeah, but that was the occasion of the 62 was the 100 years of MIT.
Yeah, that's the
That
book
was
right
it.
there.
Yeah, the
Yeah.
centennial. Was the centennial of MIT, yeah. Was on that occasion.
Oh, this is a big burger book.
Yeah.
Why don't we
Not anymore. Make the biggest machine.
Biggest? Well, you have to define biggest.
Well, all right.
Sounds like Bill Morris
Cray.
had tongue-in-cheek.
Talk
when he
about the
asked
highest
that.
performance machine.
Yeah.
Yeah, I'm quite disturbed. because there are
The indications are that he thinks it won't be very long.
The Japanese will do it.
Yeah, but he's doing everything he can to prevent it, too.
Yeah. I don't know whether he's doing everything he can.
Well, I think a CDC, for example, could put money into making a very big machine, and one has to be sure that the government doesn't simply spoil things.
But they don't want to wipe out Cray.
Look, I think that the
Well,
problem
they
is
won't
that,
wipe out Cray, but the point the government can spoil things.
that
If the government says, oh, we're going to put $250 million into a super machine and then doesn't do it, then all of the companies will say, well, there's no sense the government will release this machine to somebody for manufacture, and if we put 50 million in, then even if we imagine ourselves to be twice as efficient as the government, we'll still have only $100 million worth, and the government will have $250 million worth, and whoever they give the thing to will beat us out. And then if the government ends up not doing it, then we'll be in a
I
bad
think
way.
John,
the key
that doesn't work that way. It's like the war on cancer, you know? Government declares war on cancer, $2 billion later. No one asks what happened to the $2 billion. They say they need $4 billion.
Well, but that's fine for the war on cancer. But if somebody else were thinking of a rival project,
But that doesn't
a
happen.
rival war, but it does happen in the computer field.
Only from the Japanese.
No, but if you suppose Norris is sitting there and saying, well, what are we going to do beyond the Cyber 205? Are we going to, and his people say, that's going to cost us $10 million to produce something beyond the Cyber 205, say $50 million capital investment or something like that. Then CDC could very well decide that no, we're not going to do that because what's going to dominate is whatever thing the government chooses to support.
Well, that's the key to the whole answer, I think, is that the normal commercial marketplace doesn't really support the long
That's right.
lead times required to get that high performance machine.
right.
So you have to view it as a national defense question of national security in the broad sense, strategic sense. And the government doesn't tend to think that way. And in fact, IBM relinquished quite a while ago its desire to be the highest performance machine because it wasn't a commercial issue.
Well, I can't agree with either of those points. You see, first of
You're
all,
running
the
true to
U.S.
form, John.
The U.S. has maintained its lead up to now in high-performance machines through the commercial.
Only through
Didn't
the
Atlas have
tricky
us
route
beat for a microsecond or so, John?
What?
Didn't the British Atlas have us beat for a few
No.
microseconds?
No.
The British Atlas was a loser. I mean, it intended to have us beat, but it didn't. I mean, it made very...
architecturally interesting, but it didn't beat us.
Yeah, right. Interesting is the
Yeah.
word. Interesting. So far as I'm concerned, when somebody designs a computer that people call interesting, it means a loser.
No, but look, the key to the government support so far has been the trickle out of Los Alamos, Livermore, and NSA and CIA.
Not necessarily in that order.
No, not in that order. I agree. But the point is that it's a very fluky and politically hazardous support route, and it's kept a few people going, like Craig.
The largest number of sales on the 205, though, have been not government, but oil companies.
That's now, lately, not in the
Last-
period when they're developing the 205.
Yeah, that's right.
Okay, I mean, now there is a market showing up for some really crunchy
People have
type.
forgotten how they bellyached about the software when the machine first came out, too.
Yeah, there was in fact, the 205 has
Isn't that a
has
standard?
come out twice. The first time is an abortive version which got re-engineered. And those are expensive things which the companies had to eat and could very well have bellied up over. So, I don't feel I'm not very sanguine about it, I guess is all I'm saying.
Well, that may be, but I know the companies are opposed to the government supercomputer project. That is-
Yeah, okay, I can understand their
There've been
reservation.
Are
several
they also opposed to that combine Norris is putting together to explore long-term development of
Well, they had-
technology?
they had to get-
No, they're
They had to get an okay from.
The antitrust.
Yeah, right.
But are they going into that wholeheartedly or with three hands
Not
hidden
this,
behind their
not
back.
this government.
No, that is no, I think they're, yeah, I think that one's going nicely. I mean, I'm pleased that IBM is out of it, and I'm pleased that the others are in it.
And
It's
in
the
the
only way
able to handle
to
it.
keep abreast.
Hey,
no
can we,
question.
Yeah, let's go back.
let's go back to our reason for being here.
This might be historical 20 years from now.
Yeah.
Why don't you go to the TXL, or do you have something
All right.
else in mind?
Well, okay, let me start it out by just mentioning kind of a set of themes, which, I've said a long time ago, and I'll say it again, but it's worth repeating. It seemed to me there were four, at least four, but four identifiable reasons why people wanted time sharing in the form that we were trying to engineer it in those days. One was interaction, the ability to have human-like response times. A second was remote access, being able to get at a machine from a distance. A third was being able to share programs and communicate with other individuals conveniently. And the fourth was the one that Bob alluded to, of being, for one individual to have access to a rather vast machine that had more resources on it than he could afford by himself. The ability to, in effect, share the equipment or resources. And the reason it seems to me important to kind of think of it in that functional way is that a lot of the evolution that has occurred, including today's personal computers and personal workstations and networks, and a lot of people have kind of naively said, "Oh, that's the end of time sharing." What they don't seem to understand is it's really been it's really time sharing. It's the same functionality that we wanted in the first place, remapped in terms of the hardware revolution, which has changed the cost of doing various things. Well, I guess so. That to me, when I kind of quickly mentioned the TX0 earlier, and said, well, somebody said that's what we wanted, and I agree with that in the sense that it was interactive, and that was to me one of the most paramount objectives we were trying to get at. And that machine indeed was interactive, even though it was a limited access machine, even though Herb thought anybody could sign up for it.
Well, that's because it was right across from my office.
Yeah, right. But in fact, most of MIT didn't know about it. And it was the right idea, certainly. It did lack software, generalized software, and it did get tinkered with every other day. I don't know, John, is that what you wanted to pick up on?
I was just let me pick up on that, because I was looking at this old memo and looking at which ones of those four I mentioned. And I didn't mention at all remote use of the computer. I did mention interactive,
Well,
but mainly interactive from the point of view
different groups emphasize different things. For instance, when GE went into the time-sharing business, the remote was crucial. I mean, they had customers all over the place.
Right. I'm not saying that these ideas were important.
Yeah.
I was just curious
Yeah.
to see which ones, which of those I had. Now, list your four again.
Interactive. Secondly, remote access. Third, sharing and communication between users. And the fourth, being able to work on a machine that wasn't crippling in its resources. In other words, a vast machine.
Can we
And
modify?
then the only one I was interested in at the time, mentioned at the time, was interactive.
Interactive, I would rank first in my
Can I
own.
modify your interactive to say interactive in appropriate languages and devices for the interaction? In other words, keyboard symbols for some people, graphics for other people, speech even for other people.
Yeah, you certainly were highly preoccupied at the time with the environmental form of the interaction. I agree, and
Mine only mentions keyboard.
yeah, we each had a tendency to emphasize what we wanted to see, and,
Right.
and
Now-
you were very keen on that.
Mine
In
does.
hindsight, was it valid or?
I think you were 20 years too soon. That's all.
Oh.
In fact, no, seriously. I mean,
Shit.
if you go to the PC or personal computer fairs now, and they are beginning to have speech input and their tablets, and the stuff is all kind of beginning to be ready for people to try to work up the hard jobs of working up all the software to go with it. It's only now that the stuff has gotten cheap enough and widespread enough that people are beginning to think about broadening the interactive interface. You know.
Let's mention TX0.
Yeah.
I noticed that I mentioned TX0 in this memo, 1959 memo. I mentioned, suppose that a programmer has a keyboard at the computer and is equipped with a substantial improvement on the TX0 interrogation and intervention program, UT3. Parenthesis, the improvements are in the direction of expressing input and output in a good programming language. Then he can try his program and interrogate individual pieces of data or program to find an error, make a change in the source language, and try again. So that was still oriented towards doing more or less conventional debugging, but using the features of TX0. Now, TX0 was given by...
That was the seeds of DDT. The DEC debugging program, right?
Absolutely right.
Well,
Written by the same fellow.
TX0 existed at Lincoln Lab from when? 6 or 7?
About that.
Well, TX0 was built at Lincoln Laboratory to test the core memory.
No, there was a predecessor,
That
the memory test
another
computer.
machine. That was another machine. You're talking about the memory
Bob
test
Fano,
computer.
I think, is right. They took the memory test computer at Lincoln and goosed it up a little bit so it could be the TX0 they gave to MIT. And the software, well, maybe I'm wrong, but
I think there was a distinctly separate machine.
you could be right.
TX0.
The modules were certainly the same.
Yeah, and this is my recollection. And when they were true for that purpose, they gave it to the E department.
And
No.
Ken also went off.
No,
and
you're
made-
mixing the
No,
two machines.
they kept it for quite a long time. They gave it to the EE department when they had TX2.
You don't have to argue with this.
Yeah,
That is
that's right.
in other words, TX0 became regarded at some point as a prototype of TX2.
Yeah.
Not to
And,
mention the PDP-1.
well, but that wasn't Lincoln's
PDP-1 came
intention.
after the TX0.
I know, but it was a prototype for it.
Okay, so it was given to MIT in 60 or 61, which,
Well, one part of MIT gave it to another.
well, all right, but when did Lincoln give it to the EE department?
It certainly was before January of 1959.
Oh, really?
And after June of 1955.
I mean, it came to MIT before you got here, is what you're
That's
saying.
right.
the
It was
second
there
time.
when I came back.
Okay,
When was that?
I came back January 1959.
I'm
it
not
was
sure you're
already
right
there then?
about that.
Pardon me?
It was already there then?
Yeah.
Yeah.
Jack Pugh
yeah.
was in charge of it.
Sure.
Jack Dennis, I don't think he'd even finished his thesis by then, I'm not sure. But Pugh was in charge of it. And maybe it had just been given because he was getting it up. And he was right across the hall from me.
Okay, now, the other thing which affected these, interacted with these projects was the PDP-1, which was first developed around 1960. BBN had the prototype. I was a consultant at BBN. And then I guess we're going to go through this in great detail tomorrow. So I only want to mention it in the extent to which it's relevant to these considerations. But Fredkin proposed time sharing, as I propagandized for time sharing at BBN, and the people who were listening were Fredkin and Licklider and Jordan Baruch.
There was another fellow who got shot.
Ben Gurley. But
Ben
he,
Gurley.
He was a deck.
he was a deck designer.
Weren't he and Fredkin working together?
Yeah,
Well,
I'll mention that.
He left DEC to go and work for Fredkin.
Why don't we get into that later?
Well,
Yeah.
let me just mention that briefly, because I imagine we'll go through it. Fredkin's going to be here tomorrow, is that right?
Yes.
Is that, the idea of that the PDP-1 itself could be time shared was Fredkin's, and he designed the basic structure of the idea, the swapping drum, the interrupt system, and so forth. And then he left BBN before that project could even be proposed. And I took it over and wrote a proposal that was sent to NIH, which was suitably funded. And then that system, the BBN one, was finished in Summer of '62. And so it was ready to use, but BBN didn't use it. Though they did immediately go on to develop a fancier system in their Massachusetts General Hospital project. Now, simultaneously with that one, when the DEC gave a PDP-1 to MIT, which was put in the same room as TX2, then there was a time-sharing project initiated for that,
Jack Dennis,
which was Jack Dennis and his students. And that one used similar ideas. It used the same swapping drum, but it didn't use as much memory. And so it was actually quite a different time-sharing system.
Yeah,
And
Jack,
it was working shortly after the BBN one. But in contrast to the BBN one, it was kept in continuous use as soon as it was working. And it was stayed in use for the whole.
had a significantly different design philosophy. Namely, he wanted to do the time sharing almost entirely with hardware, and he wanted each user to be able to run his own I/O. So he wanted each user to control I/O devices.
Aha.
So it was quite a different design and required extensive. The reason it was significant is it required extensive fooling around with the logic of the machine. And one of the complaints that users had was that the machine never stood still, and people kept wondering whether he shouldn't lay off and let him get some
That
work
was
done.
probably Jack's experience from the Model Railroad Club, the club where the track never stayed still either.
John, you said something earlier in the morning that I wanted to pick up on, because you said that you mentioned your background. You were up at Dartmouth and before coming to MIT, and since Dartmouth subsequently picked up with time sharing in the form of developing BASIC, I wondered if you influenced Kemeny, or whether Kemeny influenced you, or what's the relationship between the two
I
of you?
hadn't remembered until Tom Kurtz told me about a year ago. And he said that that he had told me about BASIC and their intent to make some kind of a system. And I said, why don't you make it a time-sharing system?
That would make sense.
And harangued them a little bit about time-sharing. And then he said they did it.
This was when?
Well, that would have been I wouldn't know when. It would, 1960, 61, or 62,
I
or
see,
something like
okay.
that. It would have been before I left MIT.
Yeah. But you were already at MIT when you talked with...
Oh, yeah, right.
Sure.
Now, the history of Dartmouth's involvement with computing is, of course, the MIT Computation Center. And then Kemeny did sort of something, was interested in computing from the beginning. And he proposed something which he called DARSIMCO, Dartmouth Simplified Computing, or something like that, which was basically a kind of macro collection where you had sequences of 704 instructions that would do arithmetic operations, x equals y gets y plus z kind of thing. But this wasn't anything that was run by a compiler or anything like that. It was merely a set of conventions for programming in assembly language. I only mentioned this because it just shows that he was started on innovation early. Now, Tom Kurtz was there at the same time I was there. Maybe he was hired the year after I was, or something like that. And he became, I suppose he was probably my successor as Dartmouth's representative.
I believe so.
And so he was in this thing. And now Kemeny thought about BASIC. Now, what I don't understand is when Kurtz said, they told me about a BASIC system, and I said, why don't you make it a time-sharing system, is what they could have had in mind before. Because it seems to me that the essence of BASIC would have had to have been a time-sharing system. But
Well, JOS wasn't time-sharing, unless I missed
It was.
Pardon me?
JOS was. JOS was.
Well, I think the
Well,
contrast is to Fortran-like, or compiler languages, which were batch or operated or something.
Yeah, right. Now, the
'Cause
key
in fact,
innovation
in
of
fact,
BASIC with
the-
regard to Fortran, well, there was a couple of things there. One was, at that time, Fortran was regarded as something that required 30 man-years.
Yes.
Nobody realized how trivial 30 man-years was. How long, it doesn't take you very long
Or
to
the
put
fact
30
that
man-years in something. And anyway, it was regarded as very impressive.
Yeah.
And to do anything like that there was a view that it wasn't feasible for any smaller computer. And so that there were a lot of projects merely to show that such a thing was feasible for a smaller computer. And the first of those to work was Perlis's IT, which later...
Well, it was actually working before Fortran, but people didn't know about it very much.
Maybe it was working before Fortran, but it
those-
was in response to the idea of Fortran.
Yeah. A lot of the early compilers were tarred with a bad performance reputation, which kept people from being aware of it.
Well, it was a very peculiar language, and then later somebody said, all right, we don't have to use this peculiar language
Right.
that uses Polish prefix or postfix or whatever. We can use Fortran. And so there was a Fortransit that translated Fortran into it. And
Well, is that where that came
Yeah, Beamer
Right.
got involved in that.
well, anyway, so that's the genesis of the Dartmouth thing.
from?
as
So
far as
Cliff
I know.
Shaw got his ideas about JOS from it then?
That I don't know.
We don't know I don't know where that came from.
Now,
Well, I
you're
know
right
Cliff
about
Shaw-
one thing. You see, the big implementation of JOS was on a PDP-6 and used the PDP-6 time-sharing system. So it just ran in the PDP-6 time-sharing
Yeah,
system.
but Cliff Shaw
But
had
there
it
was a
on
previous
Rand's
implementation
machine.
on...
Did it ever get implemented on the 6? It was the first one was on the Johnny
Well, that's right. That's what I wasn't
which-
paying too much attention to, right?
which was so unique and customized that nobody could imitate it, and nobody tried, and so it was kind of a big demo that continued to work for Rand.
JOS's main feature was the universal error message.
Oh yeah,
Right.
that's right.
Very
That
useful.
Kind of a running joke.
That is, they never considered that it was necessary to tell the user what mistake he'd made.
That's all right. We had a compiler on early Multics development too. This early PL1 compiler, which had a single error message, error, which was
That's a
frustrating.
useful bit of information.
Yeah.
Now, there are a couple of strange wrong ideas that turned out to be subsequently wrong. Is that this initial proposal for time sharing claims that it would actually save computer time.
I never claimed that.
Right.
I thought it would
But I
take
did.
double.
I felt it was necessary to.
What did you mean about saving computer time at that time?
Well, the argument was simply this, that people took large dumps,
Yeah?
and these dumps required conversion of one kind or another. And therefore, if you had a very efficient system in which you could poke directly, then you wouldn't need to take a large dump, and therefore you
Unless
might
get
save computer
terribly
time.
nosy.
Well, we were already beginning to take a kind of an overall system view of it, though. Namely, we were trying to optimize the ability to write programs and solve problems, and in particular, optimize the time of the individuals. And it was quite obvious by watching this kind of horrendous process of picking off a comma mistake in Fortran, the huge amount of resources that were being wasted to find out
But
that.
for IBM, that was profit.
Yeah,
You know?
right.
Oh, yeah.
I went down to the mat with them twice about Holler's statements because it was clear in my computer course the kids were spending half of their computer time miscounting
Sure.
alphabetic characters, right? But IBM had no interest in doing it. One guy pulled me aside and said, "Guess what we're in business for? To sell computer time."
Yeah.
I couldn't argue with him.
Well, fortunately, we got past that point.
This was the same guy who told me punch cards would live forever.
Yeah, right.
All right.
Probably
now,
You probably will.
let me make,
Similar statement was made by General Motors.
There's one.
let me make the following the summary of my memo is as follows. It had 5 points. We may be able to make a major advance in the art of using a computer by adopting a time-sharing operating program for our hope for 709. 2, such a system will require a lot of advanced preparation starting right away. 3, Experiments with using the Flexo connection to the real-time package on the 704 will help, but we cannot wait for the results if we want a time-shared operator program in July 1960. The cooperation of IBM is very important, but it should be to their advantage to develop this new way of using the computer. And 5, I think other people at MIT than the Computation Center staff can be interested in the systems and other engineering problems involved. I was grossly over-optimistic.
What was the date on that, John?
January 59.
Oh, January 1st.
Well, we had, there was this kind of wishfulness that we could influence the manufacturers to change their ways. We were already in the era where universities had basically begun to relinquish their ability to build computers in competition with manufacturers. So my recollection was that Illinois was still maybe hanging in by their fingernails, but everybody else had kind of given it up as too much big-time engineering for a university to get into. So the universities had dropped out of the market of building computers, and therefore their only chance to innovate was to persuade manufacturers. And that was a difficult situation, and that's in fact was one of the goals of Mac, I think, was to try to set the pattern for manufacturers. And the genesis of Mac was involved using the second copy of CTSS as a kind of an instant demo. It wasn't intended to last forever, and to go about the process of doing the project of RFPing for a real time-shared computer, the very project that we'd been basically talking about in '61, but which we never really got down to the mat on. And that indeed did happen in Mac. We went around and did a machine search, or interviewed manufacturers. We kept getting, and basically it came down to just a handful of companies that were in a position to do anything.
Which ones were expressed interest?
Well, at various levels. Let me see, Bob may want to. Well, there was IBM, certainly.
IBM.
Burroughs never did, really.
Well,
Univac was yes and no and yes and no, and finally they said no. DEC was very interested. General Electric came in, but as a very, very late entrant.
We didn't realize.
CDC, we went there, but we didn't go very far because Seymour Cray, he didn't want to talk with us.
He hadn't left to set up his own company yet?
No.
He's still on the board and also a chief designer.
And they didn't really come through with anything. So in the end, the only three that made a proposal, actually, in the end, were General Electric, IBM, and DEC. Those were the only three that came out with a definite proposal. So they were the only three that were seriously considered.
Now, if we had sent out our RFP in 1961 and had gotten responses like those, I would have been terribly disappointed, because I think that the GE machine that was selected was really quite in fact, I would have preferred a stretch to the GE machine that was selected.
Oh, well.
Well, you weren't around. You didn't stick around to have your
Luckily, John,
influence.
both of us were out of the loop.
The reasons for picking the GE machine were, by that time we had turned our attention to, instead of trying to acquire a very large memory, we were trying to acquire a good virtual memory environment.
Yeah.
So paging and segmentation and the ability to talk about parallel processors were viewed as important design objectives. Okay.
Look,
Did you have
if you're getting
contacts
into
high
that,
up
I
in
think
the
we should go
company?
back first to the origin of Mac before we get into this, because there is a whole history of, let's say, how the thinking kept developed during that period that leads to this. We have to pick it up in the beginning.
Why don't you give that?
certainly the idea in my mind when we formed Mac was very much key to launching the notion of a computer utility. There was no question about it. It was not just time sharing. Time sharing was a tool. The idea was to launch the notion of a computer utility and man-machine interaction. Now, as a matter of fact, this is how the name Mac was chosen. And this is a little bit of an amusing story, so I want to say it. Dick Mills was the first employee of Project Mac. When he appeared on, I believe it was in March 1st, that's when we were authorized informally to start spending money. Dick came in as my assistant director. He went to the various MIT offices to get this paperwork done. Among other things, went to get a parking sticker.